So here we are with the restored JTM45. Let's call it a kind of transitional JTM45 to JMP. And I say that because this is a factory EL34 amp, which is fascinating. But the circuit and the way this is put together, absolutely a JTM45. All right, so it's a JTM45 with an EL34 spec'd output transformer, and was factory EL34. So really kind of transitional when we're heading into the lead spec and the base spec JMPs, the 1986 and 1987 model circuits. So let me just talk through the restoration work that I've done here, and I'll kind of do it and compare it to the amp that we received here. So the first thing that you might notice is compared to the walkthrough in the part 1 video is that I've taken out these extra filter caps that were kind of shoehorned into the amp and cable tied in. Pretty weird. Both of those caps were actually in parallel with this guy, and this is the filter cap for the entire preamp. One filter cap, the entire preamp per JTM45 spec. So with the addition of those things and the value already here, we had 70 microfarad filtering in the preamp, and I don't know, I can't work out why someone did it. I honestly don't know why, but be that as it may, it was there. So those have come out. I've added this. This is a period correct, new old stock, 470 picofarad ceramic cap, and it's on the mixing resistors here. This was supplied to me by my good mate Warwick Newman. He was from Tone Revival here in Melbourne. Is a great amp tech and a lover of vintage Marshalls, so we have a lot in common. So thanks, Woz, mate, I appreciate that. This amp is worthy of taking something from your stash, so I do appreciate it, and I'm sure Chris, who owns this amp, will appreciate it even more than I do. So these are 270k mixer resistors here. So in a JMP era Marshall, or right up to modern day reissues, including the JTM45 reissue, what we see here is 470k mixer resistors. Now they're called mixer resistors because what's happening here is your guitar signal as it comes off either the normal channel volume wiper or the treble channel volume wiper, they connect into here. So this is a normal channel here, this is the treble channel, and they come together at this point, as you can see, and then that green wire there is connected to that point in the amp, and the green wire takes us to the grid or the input of V2A. All right, so that's kind of like mixing the two audio signals, especially if you've got the amp configured with jumping. You're jumping the channels and you're mixing, you're dialing these two in separately. Your signal will come in here and mix together. So there was no treble pica cap there, and that is 470 picofarad there is as per so very, very early JTM45 schematics has this. Now the 270k mixer resistors is not common. Mostly you'll see 470k here. This comes from the Fender Bassman for 270k, right, which is, as we know, is where the JTM45 came from. I sent some pictures of this to Dave Freeman, got Dave to check it out with me, give me some pointers, and he said, yeah, very rare to see 270s in here like that, but he agreed that adding that cap would be a good idea. It definitely sounds great. I mean, you do it because we're trying to get this period correct, but also I think it just sounds, the treble channel sounds better with that in place. Here, which is the the coupler or the coupler cap for the mid control, it had the kind of a weird, I'm just getting down my parts box here, the ceramic 22 nanofarad cap was in there, definitely not original, so that came out and I put in one of the mustard caps that Chris had supplied me. Brought bright cap on the treble channel here. This is 100 picofarad. Again, JTM45 correct spec. And it came from my vintage parts drawer where I've got just a collection of, odds and sods from over the years, bits and pieces in there, right? So it's an old cap. It's 100 picofarad. Again, I reckon it really works nicely in a JTM45. We had some orange drop caps that had been put into the phase inverter, so they've all come out, and we've replaced them with, again, the mustards that Chris had supplied. Here's the input to the phase inverter here, and here's our 0.1 couplers for the phase inverter. Bias supply, let's talk about that. So this was fixed bias, like fixed, right? So it's a fixed bias amp, as you probably know, not cathode bias, but it was so fixed that you couldn't adjust it, right? So what we had was our normal Marshall bias setup for a 45 or a 50 watt amp, where we've got a 220k dropper here coming straight from one of the high voltage secondaries, okay, through the diode, 15k resistor here, and then what we had was a 56k resistor to ground with no trim pot. All right, so there's no way of adjusting the bias in the amp, and the tubes were biased cold. They were set quite coldly. So I reckon it was about somewhere bit like 45% plate dissipation, something like that. Pretty cold. So reconfigured that. We've changed this to a 47k. This is a 50k trim pot. And now we have an adjustable fixed bias amp, and I've biased it to about 65% plate dissipation. So not stupidly hot, but certainly better than it was. Now let's talk about the rectifier and the B plus setup, because there was some weird stuff going on in this amp, and this has now all been reconfigured and kind of again put back to what I believe is period correct, and makes the amp sound better as well. So the first thing we're going to look at is this rectifier tube down here, all right, or rectifier socket I should say, down here. This was wired in as a solid state rectifier, okay, you remember that from the part 1 video if you saw it, and we had these guys kind of wired into it, which were just good old standard diodes put into series configuration and soldered straight into the pins on this socket here. So this has now come back to GZ34 in here, right, rectifier, and is all back to standard, stock wiring. This can cap here, which is in parallel, it's a dual can cap, but it's in parallel. This is the filter cap for the mains, right? So this is coming straight off this guy, and that's our mains filter cap. And it connects into this point in the amp here. And this point here is, the mains B plus. And from here, we've got the black wire here, which is one side of the choke, and we're coming in to this black wire here, which is the other side of the choke. So this point in the amp right here is the screen supply node, okay? And then we've got an 8.2k dropping resistor here that takes us to the phase inverter supply, which is this point in the amp. All right, so this point in the amp is the same as that point in the amp, and that's our phase inverter supply node. Now, I set this, I originally had 10k here when I was working on the amp, and I moved it down to 8k2 because I'm searching for between 320 and 330 volts DC at this point, junction of the 82k and 100k resistors in the phase inverter. These are the plate resistors for the PI. I like 330 here. 320 is okay, but I'm kind of looking for 330. And from there, the rest of the voltages in the amp will be kind of in spec. Right? I just think Marshall's, this kind of circuit sounds best with 330 here. So I adjusted that accordingly. This can cap on the side here, I was suspicious about it at the beginning when I looked at it at the amp initially, but I've been through and checked multiple times all of the readings on these capacitors, these filter caps, the bias filter caps, the filter cap for the preamp as well, and they all measure fine. Right? And I am in the camp of not replacing vintage filter caps, can caps, if they don't need to be. Right? I know there's people out there that, techs out there that will replace these as soon as they see them because they look at them and go, oh, they're old. If they're working, my philosophy is leave them. Right? Why replace them in a vintage amp if they are okay? Chris, who owns this amp, he lives locally. He's not far from me. If he's ever need replacing, he knows where to come. But I don't want to take these out of a vintage amp like this unnecessarily. I mean, why would you? Look at them. There's always a risk, of course, that if you change any of this stuff, it will change the tone of the amp and the feel of the amp, and we don't want to do that because this thing sounds pretty unreal. What else have I done here? Right, so just on this B plus supply, you might remember from, well, the rectifier, I should say, you might remember from part 1 video that it had this weird 15 ohm resistor. It was in series, in line with it, okay, and that was to knock a few volts off the B plus line. And then we had this 1K resistor here, right, this old guy, which was the dropper between the screens and the phase inverter. And as I observed in the part 1 video, the voltage at our phase inverter node was way too high. Well, way too high in my book anyway. So we will power this up and we'll do some voltage readings through the amp so you can kind of see how it's all hanging together. I'll get the LCR meter out as well and show you how these old filter caps are performing. And probably the last thing that I'll mention with respect to the restoration here is that I did put 1K screen grid resistors here. You can see them. All right, so the way the amp was wired, we were coming, this orange stuff is all original wiring. It was coming straight off the screen supply node, straight on to straight onto the screen pin here. Okay, pin number 4. And even in the Fender Bassman, right, Fender Bassman schematic, you'd have 470 ohm resistors here. And then in the very earliest JTM45 schematics, 470. Now, as we said, right, this is an EL34 spec amp. EL34s want, safer with 1K in here. So look, I know it's not, they weren't part of the stock factory amp, but I think it's a good move in terms of keeping this nice and stable and not risking, having something terrible happen with the output tubes that might do something that will damage this vintage output transformer. So that is the restoration, I think, guys. Let's do some measurements in this thing, and of course we're going to have a listen to it. Okay, so I've got the LCR meter going here, measuring capacitance, and I'm just going to go through, show you how all these caps are performing. This is the mains filter cap, right? So it's a dual 16 microfarad can cap, parallel together. So this by spec it should read 32. We've got 35. This thing's fine. All right. You'll notice also I'm measuring at a defined frequency here. So LCR meters actually measure, based on a frequency that you're inputting into the cap, and 100 hertz is what a rectified AC here in Australia would be, right? 50 hertz at the mains, and when it's rectified, it doubles in frequency. So 100 hertz, you're testing the performance of the cap at 100 Hertz. Let's go to the can cap on the side, which is where we've got our screens and phase inverter nodes, filter cap, right, dual can cap. One side is 29, so this is the 32 microfarad spec side. 29, it's okay, right? I'm not gonna play with that. We'll change it, I should say. Other side, we should get 16, and it's 16. All right, these are fine. Let's have a look at the bias. All right, so these are 8 microfarad, these caps, and the measuring, you know, both of them are measuring very close to one another. I mean, I'm obviously measuring this in circuit, but the LCR meter is pretty good at doing that. Occasionally you need to pop the cap out to measure it properly. And here is the filter cap for the preamp, which is a 32 microfarad cap. And again, you know, we're at 35. As I said, these are all fine. I'm going to leave them alone. Let's go through some voltage readings, right? I'm going to go straight to the mains filter cap here. 389. So we can see, right, if I just show you kind of what I've got on the power switch here, 239. Let's just bring this right up to 240 on my variac, so we're right on. Close enough. Go back to DC. 391, 392. This is the same point in the amp, as I said, yeah. So let's go to, so that's our mains, right? And that corresponds to, sets up for the plate voltage, right? Pin 3. Right, the difference between this reading and this reading, which is, you can see a volt or two down, is because there's a voltage drop across the primary of the output transformer. Right, so these red and white are from the primaries of your output transformer, and the brown one here, which is connected to this point, is the center tap of that primary wind. Through the choke we go. This is the screen supply node. Okay, and then through our 8.2K dropper, this is the phase inverter supply. And as I said, I wanted 330 here, so I'm very happy with that. There it is again. Okay, and then that then goes through the 10K dropper, which is just placed in on underneath. It's just kind of on this side of this filter cap here, and this is the supply node for the entire preamp. I can get a reading on it. Here we go, 282. And if we go to the preamp, you can see that that 282 is coming in here on each side of these 100K plate resistors. Okay, so this is the actual voltage on the plate of V1A. And this is the voltage on the plate of V1B. And you can see they're the same. The reason they're the same is because they share the same cathode resistor, which is this 820 ohm resistor here right at the edge of the chassis. All right, guys, here's the voltages in our JTM45. We're going to hear how it sounds.